Good morning, ladies and gentlemen. Today, let's discuss a quick review of energy. So, energy. When defining energy, we define it as the ability to do work. So, what does that mean? That to do work, we must have some energy. Well, from there, we talked about two types of mechanical energy. The first type was kinetic energy. And the second type was potential, right? We talked about gravitational potential energy. So potential energy, right? Even in parentheses, you can put gravitational, which we know that's just potential energy dealing with gravity. Well, going to our kinetic energy, we have an equation on our reference table that says kinetic energy equals 1/2 mv squared. This right here is an important equation for kinetic energy. Now, we have our second thing that we need to know for kinetic energy, and that is our units. All units for energy are joules. So our units for kinetic energy will be joules. We call kinetic energy the energy of motion. So for there to be kinetic energy, our object must be moving. For our potential energy, right, when we're talking about gravitational potential energy, we have our equation that PE equals mgh. PE equals mgh. Again, that is also on your reference table. Our units here are going to be joules as well. It is energy. Well, talking about gravitational potential energy, we know that that is the energy of stored energy, right? All this energy is stored, which means it's not moving, which means it only relies on its height. Its height. So if you see here in kinetic energy relies on speed, potential energy relies on height. So those are the two types of mechanical energy we talked about. Well, once we finished from there, we went on to talk about conservation of energy, which the whole big idea of conservation of energy was that energy cannot be destroyed nor created. Right? So it is not being destroyed nor created, right? Whatever energy you have before is the energy you're going to have after. Right? And the examples that we used showing this was the pendulum and dropping a ball. And these were our examples we did. Now, the last thing we talked about, and was the thing we discussed today, was the work-energy relationship. The work-energy relationship, or you can call it work-energy theorem. Right? We'll just say relationship. And well, what that means is that we said that work is equal to the change in ET. Change in ET. Well, we know that ET, and we'll put it over here, ET is equal to the total amount of energy. And we are given that ET equals, again, this is on your reference table as well, ET equals potential energy plus kinetic energy plus internal energy, right? Which is heat, friction, things like that. Just breaking this down for you so you do have it broken down, we can say that change in ET equals total energy final minus ET initial. We'll break that down further. You know that ET is PE plus KE plus Q. So we're just going to use those finals and those initials. So PE final plus KE final plus Q final minus PE initial plus KE initial plus Q initial. And all of this is going to equal work. Then you can go through your problem and cancel out what needs to be canceled out, what is there and what is not there. But before we go back into this,